Hello friends, welcome to Aptdemy's live class. Today, based on your feedback, we consider ellipse problems. So, this is one problem. Let us see what is the statement of the problem. So, let P and Q, whose coordinates are x1, y1 and x2, y2. Remember, y1 is negative, y2 is also negative. Be the endpoints of the latest spectrum of the ellipse x square plus 4y square equal to 4. The equation of the parabolas with latest spectrum PQR, which are correct out of these ABCD options. So, given equation of the ellipse is x square plus 4y square equal to 4. That means x square by 4 plus y square by 1 equal to 1. Therefore, this represents a standard ellipse like this. Let me draw it more properly. So, this is x-axis, this is y-axis, this is center of the ellipse, which is nothing but origin 0, 0, and this is first focus of the ellipse, this is another focus, f2 of the ellipse. Now, from this given equation, I can say easily that A is 2 and B is 1. Semi-major axis is 2 and semi-minor axis is 1. And E square is, you know, this 1 minus B square by A square. So it is 1 minus 1 by 4. So it is 3 by 4. So E is root 3 divided by 2. So E is root 3 divided by 2. Let me note down somewhere here. So what is the coordinates of focus? Plus minus A, E, 0. That means A is half, A is 2. So plus minus 2 times root 3 by 2, 0. So the coordinates of focus are actually F1, F2's coordinate will be plus minus root 3, 0. Okay? Plus minus root 3, 0. Not 3, root 3, 0. Up to this, there is no doubt. Now, latest spectrums are like this. So, this is one latest spectrum passing through focus line perpendicular to the axis. This is another latest spectrum. So, this is F1, this is F2. And F1 and 2's coordinates are like this, root 3, 0 minus root 3, 0. Now, these are latest spectrum. PQ be the endpoints of the latest spectrum such that y1, y2 are negative. That means they are referring to these 2 points, P, Q. So PP dust is one latest spectrum, QQ dust is another latest spectrum. So what is the coordinates of endpoints of the latest spectrum? So the x coordinate of both P and P dash and Q and Q dash, for x coordinate of Q and Q dash will be root 3, And what is the y coordinate, that you have to find out. Here also it is root 3. Y coordinate we have to find out. And for p dash it will be minus root 3, comma, I will find out what is that. And here it is minus root 3. I will find out what is the y coordinate of p. Now, if you substitute here x square equal to, sorry, not x square, y square equal to 4y square is equal to 4 minus x square. So if I substitute root 3 over there, so it is 4 minus 3. So y square is 1 by 4. So y is plus minus 1 by 2. And similarly, if you substitute y equal to minus root 3, again you get y equal to plus minus half. So these points coordinate will be root 3 half. This points coordinate will be root 3 minus half. And here it is minus root 3 minus half. And here it is minus root 3 plus half. Okay, so P's coordinate is minus root 3. P dash coordinate, this is P, the point P dash. P dash coordinate is minus root 3 half. Q dash coordinate is root 3 half. P's coordinate is minus root 3 minus half. And Q's coordinate is minus root 3 minus root 3 minus half. Okay, so these are the coordinates of P and Q. Now what is there in the question? P, Q, y1, y2 are negative. That means they are referring to this point P, whose y coordinate is minus half, and Q, whose y coordinate is minus half. Okay. Now let us talk about the line PQ. The equations of the parabola with latest rectum PQ are what? So join this line points PQ. So with PQ as latest rectum, if we draw parabolas, then what are the equations of the parabola? So this is PQ is the latest rectum of the parabola whose equation we have to find out. So what is the length of PQ? Length of PQ is actually, sorry. So length of PQ, if you calculate, it is how much? It is this much is root 3, this much is root 3. So root 3 minus root 3, this is 2 times root 3. Length of PQ. Now there can be just try to draw the parabolas which are possible with PQ as latest rectum. So focus of the parabola must lie on this line PQ, and it will be midpoint of PQ. So what is the focus of the parabola? So midpoint of PQ is the focus of the parabola. Obviously, because we know from our basic knowledge, and that is midpoint of PQ is how much? It is minus root 3 minus half, it is plus root 3 minus half. So it is 0 minus half. So coordinate of focus of the indented parabola is 0 minus half, which lies on the y-axis. So this point is 0 minus half. So with 0 minus half as focus and PQ as latest rectum, which parabola we can draw? So what happens? The length of the parabola, length of the latest rectum of the parabola is 2 root 3. So length of latus rectum is 2 times root 3. So 2 times root 3 is how much? For a parabola, you know, length of latus rectum is 4 times the focal length. So 4 times the focal length. If I call focal length of the parabola as f, so 4 times f is equal to 2 root 3. So f is actually root 3 by 2. So focal length is root 3 by 2. Alright. 4f is 2 root 3. So focal length is 2 root 3 by 2. 4, that is root 3 by 2. That means if this is focus, then if this point is focus, then focal length is root 3 by 2. It indicates that the vertex of the intended parabola will be root 3 by 2 distance away from the focus. So this is focus and this is the line, this is the latus rectum. So axis of the parabola will be perpendicular to latus rectum. So axis of the parabola is obviously y dash, because y dash must be axis of the parabola. There is no doubt. Why? Again, since PQ, which is a line parallel to x-axis, is the latus rectum, and 0 minus half, this point is the focus of the parabola. So axis of the parabola is a line passing through the focus and perpendicular to the latus rectum. Therefore, y dash is the axis of the parabola. Now the vertex of the parabola must lie on the axis of the parabola, and it is how much distance away from the focus? It is focal length away from the focus. So focal length we have found, which is root 3 by 2. So it is vertex of the parabola, it will be minus of coordinate of vertex. If I call this v, vertex of the parabola, the coordinate of v will be how much? It is 0 minus root 3 by 2. 0 minus root 3 by 2. That means from the focus it is root 3 by 2 distance below the focus. Or there can be another vertex. If I call this v1, the coordinate of v1 will be 0 minus root 3 by 2. It can be on the positive side of y-axis. So if it is here, focus is here, so v2 can be this side also. And coordinate of v2 may be, in that case, what happens? It will be minus half plus root 3 by 2. Okay. So it is, because this coordinate is minus half plus root 3 by 2. So 0 minus half plus root 3 by 2. So 0, let me draw, 0 minus half plus root 3 by 2. Okay, so we have to find the equation of the parabola whose vertex is at 0, root 3 minus 1 by 2. This is v2's coordinate, this point's coordinate, 0, root 3 minus 1 by 2, or its vertex can be at 0 minus root 3 plus 1 by 2. Okay, so if these are the vertex and focal length, if it is root 3 by 2, then what is the equation of the parabola? Obviously, the equation of the parabola, you see, parabola will look like either this passing through Q. Either it will look like this or it will look like this. It can be this parabola with vertex at V2, focus at 0 minus half, or it can be this parabola, vertex at V1, focus at 0 minus half. So what are those equations? So if I call these are the two parabolas, one parabola. So what are the equations of those parabola? So what happens? Just let me write down. So x square, these are parabolas symmetrical about y-axis. So equation will be x square equal to 4 times the focal length, so root 3 by 2. X for this parabola, it is x plus root 3 plus 1 by 2. This is the equation of this parabola, red parabola, because its vertex is 1 plus root 3 by 2 with a negative sign. So it is x minus root 3 plus 1 by 2. So it is x plus root 3 plus 1 by 2. And you see, if x is less than minus root 3 plus 1 by 2, the quantity x square becomes negative. So we do not get, it is y, not x. This is y, sorry. This is y. So x square, if y is less than minus root 3 plus 1 by 2, then what happens? This quantity becomes negative. So x square becomes negative, x becomes imaginary. So we do not get any real x if y is less than minus root 3 plus 1 by 2. So this is the equation of the parabola, this parabola. If I call this as P1, so equation of P1 is this much. And equation of P2, if I call this parabola as P2, orange parabola, this parabola, whose vertex is at 0 root 3 minus 1 by 2, its equation will be how much? Its equation will be x square equal to minus 4 into focal length y minus this vertex is what? This vertex V2 we have found root 3 minus 1 by 2. So 1 minus root 3 minus 1 by 2. And you see, if y is more than root 3 minus 1 by 2, then parabola x square becomes negative. If y is more than root 3 minus 1 by 2, this quantity becomes positive and x square becomes negative. So x becomes imaginary. So the equation of P2 is like this. So this is P2's equation. So what I can write from this actually? So from the equation of P1 I can write x square is 2 root 3 y, 2 root 3 y plus 2 root 3 multiplied by root 3 plus 1 by 2. So it is root 3 multiplied by root 3 plus 1. So it is 2 root 3y plus 3 plus root 3. Okay, so x square is 2 root 3y plus 3 plus root 3. So x square minus 2 root 3y, x square minus 2 root 3y. So x square minus 2 root 3y is equal to 3 plus root 3. So this is one equation which is nothing but this parabola P1. Okay, so P1's equation is x square minus 2 root 3y equal to 3 plus root 3. So what is that? Let us take x square minus 2 root 3y equal to 3 plus root 3. X square minus 2 root 3y. This is x square minus 2 root 3y equal to 3 plus root 3. So B is correct answer. B is the solution for P1. B is the equation for P1. And P2 is how much? P2, if you write, it is x square plus 2 root 3y. or x square plus 2 root 3y is equal to how much? It is 2 root 3 into root 3 into root 3 minus 1 by 2 with a negative sign. So it becomes root 3 times root 3 minus 1. Okay, so it is how much? It becomes x square plus 2 root 3 y equal to 3 minus root 3. This is the equation of P2. So here where I get this thing, x square plus 2 root 3y equal to 3 minus root 3. This is x square plus 2 root 3y equal to 3 minus root 3. So this is the equation. That means C is also the correct answer. So B and C, this equation, and so B and C are the correct answer. B is this equation, and C, which is this equation. These are the correct answers. So it is B is actually how much? B we have got x square equal to x square minus 2 root 3y equal to 3 plus root 3. This is B, and C it is x square plus 2 root 3y equal to 3 minus root 3. So these two are the correct answers. So B and C are the correct answers for the problem. Okay, so here what we did, since we started with the given equation of the ellipse, we determined the coordinates of the focus, we drew the lattice rectum. With lattice rectum, midpoint of lattice, with this lattice rectum, PQ is the lattice rectum of the intended parabola. So midpoint of the lattice rectum is the focus. We found from the length of lattice rectum the focal length of the intended parabola, and from that we determine the possible vertices of the intended parabola. We got there are two possibilities. One vertex is at V1, another vertex is at V2. V1's coordinate can be 0 minus root 3 plus 1 by 2, and V2's coordinate will be, we determine V2's coordinate is how much? 0 root 3 minus 1 by 2. So with these two vertices, what are the possible equations of parabola? We determine whose focal length is actually root 3 by 2. And these two equations are like this. And from that we found that B and C are the correct answer. I hope you have understood. It is a problem where concepts of both parabola and ellipse are involved, and with clarity of mind you can easily deduce what are the equations of these two parabola. I hope it is clear. Okay, thank you.